Hello everyone. So in this video we will be discussing the lab regarding the decomposition of malachite. So you've learned about the types of reactions. Decomposition is one of those. And now we're further applying knowledge of stoichiometry. Um, so you are using your knowledge on types of reactions and also on stoichiometry, which has to do with converting between, let's say masses of your reactant, converting it all the way to, let's say, and I say that because you can choose many different things you can convert it to, but let's say the mass of the product. So that's the idea here. So overall objectives are to heat a known mass of malachite to produce copper oxide. So it's a reaction that's occurring. So you're starting off with this kind of really big molecule called, not molecule actually, sorry about that, a really big compound called malachite, and then it's turning into copper oxide. It's decomposing into that. So you'll identify the products formed. We actually already have the balanced chemical equation, but you're going to use that. That's going to be part of it to test if the relationship between malachite and copper oxide is in fact stoichiometric. So you will confirm that. So as always, you are going to open up your Hayden McNeil account. You will log in there. I already have lab 7. It should be showing once you once you happen to be opening it up or seeking to open it up. You are going to open it as always by clicking the green notebook icon. You're going to read the intro. It's short and sweet as always, and it provides you the equation, especially, or the setup of how to convert to moles, which is really important for us. And then on page 2, you can actually access the simulation itself by clicking this virtual lab simulation icon. You're going to complete the entire procedure. There's no separate, sub experiments for this particular lab. You know how on some of the other labs you've had like experiment 1 and then experiment 2. This one's just all one procedure, so you don't have to worry about omitting or completing, separate experiments. You're going to collect your data as always in part 3 of this handout that I'm showing here. Now, some general notes and tips just to remind you once again, because some of these are repetition at this point. So if you've seen some of these notes previously and you're like, hey, didn't we already talk about that? Just reminding you. So use the correct chemicals and correct concentrations. That's just a general reminder as always. Just make sure to start off with the correct chemical. For example, if you're not actually starting with malachite, you complete the entire procedure, you're not going to get the results that you're aiming for. Remember that the lab simulation system is kind of finicky. Double clicking may not always work the first time, but it's okay. Be patient. Try it again. When you place the crucible on the Bunsen burner, remember to place it directly on the burner, not like kind of with space above it. And then in order to see inside the crucible, remember that you can double click it and that opens up the crucible to let you have like a cutaway view for this. And then finally, be on the lookout for the distinct color change that will happen once the decomposition is fully complete. So you will see a distinct color change when the malachite is fully decomposed. And then you will upload the lab. You're going to complete it all. I'm going to show you the data collection portion right now. You're going to complete it and then upload it to the assignment link on Blackboard. So what exactly are you collecting? So you're collecting some masses. So as a general um, what's the phrase I'm looking for? As a general, um, just in terms of sig figs, record all your masses to 3 decimal places because that's what you have available for you in this lab simulation. That is the precision of our instruments in this lab simulation. Now, here is the balanced chemical reaction equation that you're using. So, what is this malachite we've been discussing? That is a common name for a compound that is made up of copper and some other elements here, which you can see. It's a common name for it. So in the same way that water has a common name, that is a common name. The scientific, chemical name is dihydrogen monoxide, but we have a common name. In that same way that water has that, we have a common name for this. So that's what malachite is. It decomposes into copper oxide, carbon dioxide, couldn't think of that one for just a second, and water. So you will be confirming this with your results that you record. So I'll discuss the steps a little bit more once we get to the lab simulation, but one thing I want to point out is what you're showing work for. So you are showing work for determining moles, and I'll come back to this in just a second. So now I'm going to open up the lab simulation. So once you log in, with your own account, of course you see the previous labs we've completed, and then you're going to see lab 7. So you're going to open up your lab 7 with the little green icon. Here is the introduction. So malachite is a popular semi-precious stone. It has these really, beautiful colors, light and dark green bands. But overall, the chemical formula for it is, what we just discussed. And when we heat it up, it decomposes into copper oxide. So that's the reaction that we're looking at here. Now, it goes into an example here about stoichiometry, right? And how when you have a chemical reaction, there's certain ratios of everything, right? So for example, here magnesium reacts with hydrochloric acid in a 1:2 ratio, stoichiometric ratio. And the way you can determine moles, for example, if you needed to, is you take the mass, you divide out the molar mass, that gives you moles of whatever you're searching for. So this is a reminder of how to get moles if you need that refresher. You just learned about this by the time you should be watching this video. You just learned about this in lecture. So here are the procedure steps. So you are going to be using a crucible. You're going to be using your malachite. Remember, it has a scientific name, copper 2 carbonate hydroxide. But for us, nickname malachite. And then essentially main idea, big picture. Remember, always have that big picture so you don't get lost in the weeds. You're heating it up, to change it, to decompose it. So remember I told you to watch out for that color change. So I'm going to go into the lab sim just to point out, where the malachite is. Start lab. As always, you're going to put on your PPE. I'm going to skip the animation. So this giant cursor I have is messing things up. Let's try to zoom in. Maybe that will help. Always troubleshooting, even me. That's copper. Yeah, that says copper. That's magnesium, and I'm sorry, my cursor's not helping. This is zinc. Okay, here we go. Copper 2 carbonate hydroxide. So make sure you're using the right one because there's a bunch in here, okay? There's sodium hydroxide, sodium carbonate, there's a bunch. So make sure you are using the correct one. Now, something I wanted to remind you of, where's our crucible? here we go. I was starting to freak out. I was like, where is it? So I'm bringing my crucible to the bench. Now, if you want to cut away, and by cut away, it just gives you a different view. That's what I mean. So to show the inside, and you need to be able to see the inside so you can see that color change, double click it, show material in container, and done. And then it'll show you everything inside. Other than that, it's the typical setup which you've, I believe, done before. Brought over your Bunsen burner, the way you turn it on. There's 3 settings. There's your low, your medium, and your high, and then off. So that's how you turn on the Bunsen burner. Just click on this little knob. Other than that, not really much different. You're using your balance. Remember, it gives you 3 decimals, so that's what I want to see on your observations, the data you record. Don't forget the unit. That's something that I use to grade on the rubric. My grading rubric includes, whether you've been using units consistently throughout the entire lab that you turn in. So I want to see all those units. Other than that, there shouldn't be anything too tricky or anything too special about this lab. You're just heating that malachite. Okay. Now I want to go back to the lab, to this lab handout, and I want to show you how you would actually complete these calculations, or give you an example. So I'm gonna take kind of like a random amount of this copper 2 carbonate hydroxide, and I'm going to show you how I am looking for these types of calculations, what I'm looking for. Okay, I have received some feedback here and there from students, like that I should actually show the calculations. So that's what I'm going to do here, or that I should give you an example, that an example would be more helpful. So I'm going to try to do that from here on out. So let's say I'm just, like I said, I'm kind of just going about, and this is where this is backfiring on me. Okay, had a little mishap, had to fix the background of this box just for the view that I have. I have it on dark mode right now, so yeah, turned my cursor to white ink instead of black ink. Anyway, so here we are. We are going to just take, like I said, a random amount of malachite, and okay, there we go. So I'm gonna say, and now it's doing the opposite to me. Wow, isn't life funny? Okay, let's say we have 100 grams of malachite, right? So we know that malachite's formula is Cu2CO3 OH2. It's a long formula. So how would we go about showing the calculations for this? So what I like to see is to see the dimensional analysis. So you've been learning about this in lecture. And like I showed you on the intro page of this lab, so I'm going to go back there real quick, right here, page 1. It told you to get moles, you take, this is the stoichiometric ratio. To get moles, period, just from a mass, you would take the mass divided by the molar mass. So essentially that's what I'm doing here once I calculate this out. Right? It's your mass, and you can say this is over 1, for example, right? Just to be consistent. And what we're going to do is divide it by the molar mass. So how do I get the molar mass of malachite? So to do that, you would be adding up, you have 2 coppers, you have 1 carbon, you have 3 oxygens, 3 oxygens right here. You actually have 2 more here, so that's actually 5. And then I have 2 hydrogens. Now, good me should be taking all the masses from the periodic table, so these masses are coming from the periodic table, and, calculating it out. Just for time's sake, I'm going to do this off camera. So if you need a refresher on how to calculate formula mass, I do have some videos on that, I think, back in one of the previous chapters. If you really need a refresher on that, just email me and I'll send you over another link of a really quick example of that. But you would just determine the molar mass, multiply the number of atoms times its mass, and then you add everything up of all the different atoms in this compound. So, got the mass, did all of that. The molar mass is 221.1 grams per mole. So how are we going to set that up? We want the grams to cancel out. So what I'm going to do is put the grams down here. The number is always attached to the grams. The number is never, this number right here, is never going to be attached to the moles right here, okay? It's always attached to the grams. So Cu2, you get the point. I'm just making sure, I write it out. Okay, so that's the grams, and then at the top, instead, what's going to happen is just 1 mole of Cu2, CO3, OH2. And then you calculate it out. So I would divide my 100 by my 221.1, and whatever answer you get, just make sure to have the correct amount of sig figs. So for here, and again, this is just like an example, I have 3 sig figs there. So technically, actually, I should have a decimal there. But imagine that the decimal is already there. That's 3 sig figs, so I would have 3 sig figs over here. And that would be your answer. So this is kind of the main idea of what I would like to see. I want to see this set up for this part right here. Moles of the malachite, before you heat. And then again, moles of what you decompose to. So the moles of the contents, which is essentially your your copper oxide. I would like to see that again for that one. So I'm going to see 2 of these. Okay, 2 of these set up. And then just to finish off, you observe that the products in the crucible weigh less. How is this possible? So just a quick, application type question to wrap this all up. And I just want a short answer in 1 complete sentence, how this is possible. What do you think happened? Hint, hint, look at the products. So just use everything you observed and kind of synthesize all that for an answer. That is it for this lab. So I know this lab video is a bit longer, but like I said, I wanted to go into an example of the math just so that everybody's on the same page. So I hope this helps, and please let me know if you have any questions.